Given the linear system of these three equations, where x, y, and z form a geometric progression in this order, find the value of the positive real parameter a. Since this is a system of equations, let's give all of our equations names. We have equations 1, 2, and 3. Because we see a positive y and a negative y in equations 1 and 2, we can add them together. Doing so, we get this. We can divide 3 on both sides, and here we get our fourth equation. Now we can substitute our fourth equation to the first equation. This gives us y is equal to 2. Now since we've found the value of one of our variables, we can go ahead and rewrite our systems of equations. The first and second equations by themselves rewritten will not help us very much because they're basically the same equation repeated. However, we can add them together to get rid of the y variable. So we get 3x plus 3z is equal to 3a plus 6. This was basically our fourth equation. And we can keep our third equation, but rewrite to y. Now our goal is to represent x and z both using a. There are two things we can do from this systems. The first is to add them together. When we do this, we get 6x is equal to a plus 3. So x would be equal to a plus 3 over 6. We can also subtract 3 from 4. Doing so, we get 6z is equal to 5a plus 9. So z is equal to 5a plus 9 over 6. And now, what are some information that we have not used yet? We know that x, y, and z have to form a geometric progression. The middle term squared, y squared, which is 4, is equal to the first and third terms multiplied together. So that is equal to a plus 3 times 5a plus 9 over 36. Now let's solve for a. We get this quadratic. Now let's use the quadratic formula to solve for a. A is equal to negative 24 plus or minus 24 squared minus 4 times 5 times 117. And then we can change the sign to a plus. All of that over 2 times 5. We can simplify this to get negative 12 plus or minus 27 over 10. And remember, a has to be positive, so we can ignore the negative solution for a, which means that a must be equal to negative 12 plus 27 over 5. This is equal to 15 over 5, which is 3. So a is equal to 3. In this problem, we use what we know about solving systems of equations. We did a lot of adding and subtracting of different equations. And we used what we know about a geometric progression to set up an equation which turned out to be a quadratic formula, and used what we know about quadratic formulas.